Okay, so in this lesson, we're going to look at determining the canonical coordinates. If you recall in the previous video, we found the symmetries for y double prime equals 0. So here now, I'm going to take a few of those symmetries and find the canonical coordinates for each of them or from each of them. And so if you look, and I'm working on the assumption you've already seen all the theory in your textbooks for canonical coordinates and how to find them and definitions, etc. So, and here, if you look here where I've written r sub x and r sub y, that's the derivative of r in terms of x, the derivative of r with respect to y, and etc. And rs, of course, are our canonical coordinates. So we're going to find them using method of characteristics. And so basically, we will get, this is basically the set of equations we're going to use. And from the first two, we get here. And this is in general how we are going to determine S. So now let's look at the first symmetry. And as you can tell, I'm not focusing on theory. I'm just focusing on methodology. The theory, you can read it in any of the textbooks that you have. I want to more show you methodology, practice, and things like that. Okay, so we have our first symmetry. And so we then write dy dx equals, and this will simplify. So we have, I'm going to continue on the right hand side just so that I can use some space wisely. So here now we will have dy over dx equals y over x. This is separable, so I'm going to rearrange and separate things. And when we take the derivative of both sides, and for now, I'm actually going to denote my R's and S's with respect to the symmetry they're coming from. So R1 equals and if I rearrange this, this means, so if I want to write it in terms of y, I get Rx. So remember to find S, we are going to use this over there. So I'm going to say S is equal to, and I'm just going to call it S sub 1 again, just to and I think I want to just kind of show how we got this. So I'm going to put this as an aside. So that is the definition of chi, right? But remember, we're rewriting y in terms of r and x. So this is what we end up having. So we get that. And remember, R1 is a constant. We treat R as constant, so we pull that out. And then from your high school and first year calculus, you'll remember. And really, if you don't remember, it's so easy to find so many textbooks. Just going to give you a quick refresher and so many things online. So that's what our derivative is, right? Our integral is. And now we are going to have, so I'm rewriting it for now, like that. But remember, we now sub back in. So remember R1. So when we do that, we are going to get S1 is equal to -1 over y. So that's finding. So our canonical coordinates associated with x sub 1 are given as y over x and -1 over y. So now let's look at so if you look here, I don't have an eta. So there is a convention or a rule that we're going to apply, and that is so this is important to keep in mind, to make sure that you're aware of and applying that. As we want to keep that in mind, okay? So that would mean, and now we go on to solve for S. Oops, I'm still in shapes. Oops, sorry. That's supposed to be that. Okay, so that is what happens with x sub 2. Now, let's look at, I'm going to skip a bit, and hopefully you'll understand the reasoning behind that. So here, if you notice, I don't have a cot. I have an eta, but okay. So what we're going to do here is when that is 0, that's what we do. So clearly we already have our sub 4 then. And all we need to do now is find S. And S, in this case, is going to be found like this. So I think I'm going to put this over here, actually. So let's just take that out and also put in how to find Okay, so here we go. All right, so that's what we have for those canonical coordinates. So just to recap very quickly, and if you notice, I didn't do all of them, right? I just did x1, and then, because x1 has both chi and eta, so I just want to break it down into steps for you. And then I did x2, because in this one you can see what to do when your eta is 0, okay? And then I did x4, because this then shows you what to do when your chi is 0. So hopefully you can take that and then use that to find your other ones, and you can obviously send me any questions that you have.